Hey guys, so many of us are still very much confused in understanding what exactly is LangChain and what is LangGraph. LangGraph is part of LangChain or LangChain is part of LangGraph. When to use LangChain, when to use LangGraph. So there are a lot of questions to be answered. So this video is dedicated to all those folks who are very much confused between LangChain and LangGraph. So we will start with understanding what is LangChain. We will understand the different components or the elements of LangChain, and then we will move to LangGraph. We will also understand how LangGraph basically works, and then at the end I have a simple tutorial to show you how both LangChain and LangGraph basically work. So what exactly is LangChain? LangChain is a framework founded by Harrison Chase. It is used for building applications with large language models. So it provides a standardized way to chain together different components in a sequential, linear manner to create LLM powered applications. So think of it this way, right? Without a framework like LangChain, your developers need to hard code a lot of things. Connection to a vector databases, uh, prompt templates, right? And tool calling. So it becomes very hectic without LangChain. So LangChain makes the developer's life very easier because using framework like LangChain, you can just use it as a plug and play thing. You can just use LangChain and start building your AI or LLM powered applications. So how this is possible? Because LangChain has different components like prompt prompt templates, reusable templates for structuring LLM inputs, variable substitution for dynamic content, right? And then LangChain has using LangChain you can make use of any LLMs, like it is LLM agnostic. You can use closed source LLMs or open source LLMs. Integration with various LLM providers is possible using LangChain. It can be OpenAI, Anthropic, Mistral, or anything. And then it has LangChain has this component called chains. That is the core component of LangChain, combining multiple components in a sequence and then trying to create a LLM workflow. That's how you can build LLM chain, transform chain, and then each step fits into the next, and that's how you basically the name gets chains. And then there is a memory component. You can have long-term, short-term memory, right, to store the conversation history. And there is also agents, and this gives LLMs access to tools, right? And then the LangChain has this last component, that is tools, where you can have multiple API calls, like is possible using LangChain, and then you can have multiple tools, where like search, calculators, APIs, standardized interface for external systems. So with all these components of LangChain, you can basically chain together a lot of things and build powerful AI applications. So I'm going to show you how to do that in the upcoming part of this video. Hey guys, so now coming to the LangGraph, what exactly is LangGraph? LangGraph is an extension of LangChain, which is built on top of LangChain, you can say, and it is built for creating stateful, cyclic, multi-agent workflows. So you can basically build or create agentic workflows, dynamic workflows using LangGraph. So it treats your application as a graph where nodes can loop back, make decisions, and maintain complex state. So think of LangGraph. LangGraph as a state machine where you can have loops, conditionals, parallel execution, and human in the loop patterns. So LangGraph basically stands out as the most powerful open source framework for building production ready AI agents and orchestrating stateful, complex and cyclic workflows. So LangGraph has some components we need to understand. The first is nodes. Nodes represent tasks, that is calling an LLM, fetching data from a database, and then there are edges. Edges define the flow between the tasks, and then we have state. state holds dynamic context. Example, messages, memory, that evolve during the execution. And here is a in the image, as you can see, here is a simplified workflow of an email agent that uses context engineering, and we are using LangGraph here. So it all starts with um, receiving user query. The user asks, "Hey, draft an email to John about tomorrow's meeting," and then it fetches the context. It retrieves user preferences. Example like tone, the grammar type to be used, the personality, and the calendar data, and then it processes that with an LLM. Uses the LLM to draft the email based on the context and the tone that we have provided, and then it stores in the memory. Next step, save the interactions as episodic memory for further references, right? And then at the end, response generation, return the drafted email to the user. So this is a simple workflow using LangGraph. And let's see now how LangChain and LangGraph are basically different from each other. So now let's understand the key differences between LangChain and LangGraph. So I'll take different aspects, and then we'll try to explain the difference between LangChain and LangGraph. So let's talk about the flow type, how the process flow basically goes, right? So when it comes to LangChain, the flow type is linear. It is very sequential, only one way. The data flows in one way. It's not very dynamic. Whereas in LangGraph, it is cyclic, graph based. Loop is allowed. It can come back again asking an LLM, "Hey, did we do this right? If not, what else to be done?" So that agentic behavior is possible in LangGraph, and that is not possible in LangChain. And then state management. It is very limited, and it is very rich in LangGraph, right? The memory for chat history is kind of very limited, whereas in LangGraph it is kind of very rich, full state persistent across the graph. And then conditionals, can you have these conditions, if not this, that, if you can't do this, if the since we did not get the proper response for the user query, can you go fetch that data? Can you do the tool calling? This kind of thing is very limited in the LangChain. And then whereas LangGraph, it is very native, conditional edges are possible in the LangGraph. And then loops are not supported in LangChain, whereas it is fully supported in the LangGraph. And then when it comes to complexity, you can only build simple chains, basic chatbots using LangChain, whereas complex multi-agent systems you can build using LangGraph. And then human in the loop, it is very difficult to implement in LangChain, whereas built-in checkpoint support is also possible in in LangGraph. And then tool calling, one shot or basic iteration, that's it. It is only one shot, only one time you can do using LangChain, that too with a linear flow. Whereas in LangGraph you can have multiple tool calling at different stages of the process, right? Sophisticated multi-turn tool use is possible in LangGraph. And then the agent behavior, single reasoning step, you don't go back in the LangChain, since it is very linear, you can't actually loop back to the previous step. Whereas it is very much possible, multiple reasoning loops can be possible in LangGraph. So these are some of the simple key differences. And conceptually, if I have to say, like, LangChain is like, do A, then do B, then C, then you're done. So it's a linear sequential workflow, right? You can just build simple chatbots or even simple AI agent using this with only maybe one tool, which when the user query is very simple and it's not very complex or dynamic. Whereas LangGraph is like, start with A, decide if you need B, If so, if yes, do B and loop back to A again and see if the loop is correct, if what we are doing is right. Keep going until condition C is met, then finish. So that's how the looping is possible in LangGraph, right? The reasoning, the looping is much more sophisticated in LangGraph. So when to use what? So you can use LangChain when you have a simple linear workflow, like translate, text, summarize, and save to database. Uh, if if you are doing something like this, then use LangChain. And even if you are building simple chatbot or simple retrieval augmented generation applications or systems, use LangChain. That should be good enough. And if you need quick prototyping, then you can use LangChain, like testing prompt templates, simple chatbots. When you are testing the prompts, how the chatbot reacts, then you can use LangChain. And then your use case is one shot. You are just single question answer uh, is what happening in your chatbot, right? Like a customer support chatbot, something like that. And basic RAG, retrieval augmented generation chatbot, if you are building, then you can use LangChain. And when you don't want, no loops or complex decisions are not needed, right? um, no loops or complex decisions needed. So straightforward processing is possible in LangChain. So you can just use it for straightforward processing pipeline, like we discussed. And that's about the LangChain. And you can use LangGraph when you need agentic behavior, right? When the AI agent can decide itself whether what actions it should take next. When the since the autonomous things are very high, atomicity are very high in LangGraph, you can use LangGraph when the user query is kind of complex and very dynamic, right? And then complex decision making is required when you want complex decision making, then you can basically use LangGraph, uh, because it can route to different specialists based on the query type. It can go on to different agents. Since multi-agent applications are possible, you can build using LangGraph. So that's when you can basically use LangGraph, like complex decision making. And then when you need persistent state, track progress across multiple LLM calls, build context over many iterations, so that's when you can use LangGraph. And then when you want to build basically multi-agent systems, right? When the user query is, like I said, user query is very complex, then you can basically use LangGraph, and then build have different agents communicating together to solve a particular problem. And yeah, that's these are some of the things, you can say when to use LangChain and when to use LangGraph. So let's see a simple tutorial, so that it makes the things very easy to understand when to use LangChain and when to use LangGraph. Let's see that. Okay, guys, so here is a basic understanding of LangChain using the tutorial. I have the complete notebook code here, the basic LangChain tutorial. We'll install some libraries and dependencies, right? LangChain, OpenAI, LangChain community, and so on. And then we'll import OpenAI API key. I will mention OpenAI API key. And understanding the prompt template. Uh, the, we know this LangChain has different components or modules, and one of them is prompt templates. So prompt template is key concept in LangChain, and they allow you to create reusable prompts with variable inputs, making it easy to generate dynamic content. So that's what we are doing here. What is the capital of France? The capital of France is Paris. And then tell me adjective joke about the topic. We are putting input variables as adjective and topic, and it will say like, tell me a funny joke about programming, right? We are again using the prompt template. Adjective we are saying funny, and then topic is programming. So once we run this uh, code, we will get, tell me a funny joke about programming. So you can basically keep changing this adjective and topic, so that the prompt templates can be customized. And working with LLMs is kind of very easy using LangChain. LangChain supports various LLMs. And here, as you can see, we are initializing the Hugging Face model using Hugging Face, and then GPT-2, and you can also use other models, and you can see the response here, right? And then and this is how the chains work in LangChain, where that's the fundamental concept of LangChain, that allows you to combine multiple components and build complex workflows, right? This is how you can combine the chains, and you can basically get uh, ask it like suggest a name for a company that makes the product, and you can fill in the product, right? And company name, intelligent home tech, and the slogan is smart solutions for your modern home. And then this is how memory is one of the components in LangChain, provides a short-term, long-term memory you can have. And you can just ask like what is the current conversation and what did we talk about, so it'll have all the context about the memory. And you can also create a simple a RAG, retrieval augmented generation chatbot or a system using LangChain. And yeah, here is what it is, right? My name is Elias. What can you do for me? Hello, Elias. I can assist you with a variety of tasks. So here is a simple chatbot type of thing, that using LangChain that has been created. And then agents and tools, you can also have different tools loaded, right? Wikipedia, LLM math. Um, so if you ask a query like entering a new execution result, what is the square root of the year Pythagoras was born? So it will go to the particular tool and fetch the answer. So this is about the different components that the LangChain has, and how you can use different components to build proper AI application or LLM powered applications. But I have another simple tutorial here, that where we are building a simple retrieval augmented generation, um, and using single store as a vector database. So we are again installing required packages, importing necessary classes. We are mentioning OpenAI API key, connecting to single store, and then performing similarity search. And there is a chat history using single store, and then we are inserting our own dummy data, and then we are creating a retriever from vector store, and then we are building a RAG chain using LangChain, right? From LangChain import retrieval QA, right? And if we run the RAG pipeline asking what is single store, uh, why LangChain is used, what is retrieval augmented generation, you can see the responses. So this is very linear, very not very dynamic, not very complex, direct question answering. And this content is already present, I think, somewhere here. We're already giving it some context there. So that's how it is retrieving. Yeah, single store is a distributed SQL database for real-time analytics. LangChain allows easy orchestration of LLM pipeline, retrieval augmented generation, combined search and generation. So I think that's where it is fetching the uh, content from. So that's how you can build a simple RAG pipeline. That's about the LangChain. I'm going to share the link to the repos in the description, and let's come back to let's go to the LangGraph tutorial. So here is a agentic workflow with LangGraph and single store database. So we are using single store as a database here. So installing required packages, importing libraries, we are setting some credentials. As you can see, we are using Tavli API key. We are using it's a search API, right, for LLMs, and URL content loader. Since we are loading some URLs from Wikipedia, it's about large language model, retrieval augmented generation, loading content from URLs, and then now next is to split that content, right? Split the documents, and then splitting the documents into chunks. And now we'll store all this into our vector store, that is single store database, storing documents into single store, and then we'll initialize the web search tool, that is Tavli web search tool, perform web search, right? And then we will build the rack chain here using the model GPT 3.5 Turbo, and then we will define the state structure in the using LangGraph, and then create graph nodes. Um, right, we need to have graph nodes to be created when we are using LangGraph. Retrieve node, there is a web search node, there is generate node. So yeah, and also decision node. Uh, we're all done with the creating the graph nodes, and then now we'll build the agent workflow, right? State graph, and then add nodes. We're adding all the nodes that we created: retrieve, decision, web search, generate node, and then setting the connections. And now we'll run the agent, right? So we'll ask a query like, what is large language model? The context is already present since we are using large language model Wikipedia. We already loaded this content. The context is already present in the system, right? For answering this question is very easy for the system because the it's already present in the local, right, in the database. And next question is, what are the latest AI developments announced in this month? This is kind of very tricky, and for this, it needs to ask the go to a tool calling, right? That Tavily tool. So it will go fetch it from the web search. That is Tavily. So question: what is large language model? So retrieving documents for what is large language model, generating answer. So this answer is already present. We since we have given the context, the answer is already present in our database. The next question is, what are the latest AI developments announced in this month? Retrieving documents for what are the latest AI developments announced this month, and then it is searching web for what are the since the context this content is not present in the context in the vector database, that is single store, and now it is generating answer. The latest AI development announced this month include Google's announcement of imaging for the latest version of the AI text to image generator, blah blah blah. And again, you can ask different questions. What is NVIDIA's latest contribution to LLMs? So this is also not present in our database, right? To go and fetch. Uh, so it is going to the searching the web because the documents, the content is not present locally, and it is getting the answer back from the web search tool, that is Tavily. NVIDIA's latest contribution to LLMs is the introduction of the NVLM 1.0 family of blah blah blah. Right? What is Microsoft latest AI news in June 2025? And that's how it is going to the web search using the Tavily tool, then finding the answer and responding back. So that's how we can basically build um, build dynamic. You can also add more nodes here. If the answer is not present here, you can it can go there, fetch different data. It can actually summarize the whole thing, and then give you a proper report in type of a dashboard. You can basically add more nodes and do much more complex things using LangGraph. So I hope you understood. The only difference I would say is, right, I mean, like, the big difference is using LangChain you can only build linear sequential workflows. I mean, like simple chatbots or text summarization, translation, and all those things. But in using LangGraph, you can build agentic applications where agents can have the autonomous behavior where they can reflect on their answers and basically do tool calling, and all those stuff. You can have many tools like multi agents also, and you can have multiple tool calling options in using LangGraph. Right. So I hope you understood the differences between LangChain and LangGraph, and uh, thanks, and keep supporting.